going to just push play here and move my guy over into a situation where we move from one actor to another. And this was the fix that we had done just before. So if you had not made that change yet, this is the case where both of these actors would be highlighting together. Now these ones I think I've messed with these ones to give me three different colors, but the effect would be the same. See, because here I go from one and I touch the floor and then I'm onto the other one. So this one previously was working because there was always that little gap in between. But when you're looking like this, previously these would just stay highlighted because the cursor never left the enemy. Okay, enough of that. We want to start to affect our our health bars and our stats and stuff like that. So I'm going to close all tabs to the right, and I'm going to close this one too. What I want to do is I want to create a an actor that is an effect actor. So if we and let me just not get to that yet. And so when we create an object in the game that that will affect the character, right? So it's a health potion, it's an area of a fire, it's whatever it is. Um, those will be actors that get placed in the world, and so I want to create a particular type of character class or actor class that is going to be an effect actor. So it's going to affect the character or the enemy or whatever, and it's going to be responsible for applying the gameplay effect and um, also, I guess, ultimately removing it. Um, okay, so what I want to do is go into public. Our class is public, and I'm going into make a new C++ class, and it is going to be an actor, and I'm going to say next, and I'm going to put it in a subfolder. Um, and I think I want to call this effect effectors effector. Let's call it effector because we've had everything as singular statement there. So the actors that we're going to put in here are going to be effectors. So well, I can see like there'll be stationary ones and maybe there's ones with movement and who knows what else. Um, so I'm going to call this one my HFX. This is going to be my kind of my base class, and it's going to be my effect actor. And I'm going to create that class. And it's very true about how how things change as you go. You learn more, you change more, and refactoring is a very common and supported idea. So, anyways, I'm going to save all this. I'm going to close out of here and come back into C++, and we've got our new actor here with all of its wonderful default starting bits. And let me just get my reference up here. Now, there's different types of gameplay effects. And we've looked at some of them already. Like we did our override modifiers when we created our gameplay effects for our initial starting attributes, starting stats and such. We looked at the magnitude calculation types, right? We created some classes for creating some custom ones. We had some attribute based ones, and I don't know if we had any scalable floats. Maybe we did. I don't recall at the moment. So those are two things that we have dealt with a little bit already. One thing that I would like to talk about and include in our effect actor is the duration policy. So there's three basic types. There's an instant one. So it's like, boom, you picked up a health potion and boom, you got an extra 30 points of health. There's duration, like, oh, I'm on fire, I'm running away, and it lasts for 10 seconds or whatever. And then there's infinite ones, which basically are applied and persist forever unless manually removed, right? Um, so there's a subtle difference between duration and infinite ones. So like a duration one might be okay, it got shot with a flaming arrow, and so it lasts for 10 seconds and it disappears. An infinite one might be I'm standing in a in a pool of lava and I'm getting burnt. I get out of the lava though, and now the effects of the burning, either immediately stop or maybe it stops after a period of time or something like that. But for the while I was standing in it, it was infinite. So I want to have this effect actor have that sense about it and or be able to select that or create it when we create it to have that selection available. And pretty much all of these are going to um, apply when we are overlapping with our character in one shape or another, right? Even that arrow, that flaming arrow that shot us, that flaming arrow is going to come in with a collision object around it, and that's going to overlap um, with our self collision, and we're going to then have that action uh, carry on. So let's look at that. Um, so where's a good spot to start here? Well, let's start with those. Basically, want to create a couple of enums, and I'm going to use the macro u enum, and it's going to be a blueprint type. And it's going to be an enum class, and it's an e effect application policy. I don't know if that needs an includer or not at the moment. It probably needs a for declaration for a gameplay effect is what I'm thinking. Um, so the policy is we want to, for our enums, we're going to have one that we can set that it applies on overlap. There would be one for to apply on end overlap. And we should just have a default or a not case of do not apply. Okay. And since that's an application policy, we should have one for removal. So I'm going to be another u enum of blueprint type and be an enum class e effect, oops, e effect removal policy. And it'll be a apply on end overlap. and a do not apply, just to have a not case. Removal policy on overlap. So let's start with the constructor of this. So if we go into our CPP file, it should already be created here for us. And we want to know, I guess, right off the top, let's get rid of this comment. We don't need it. Do we want this actor to tick? And I think we can say that it doesn't need to tick because it's just going to apply something when it gets overlapped. So it doesn't have to tick. But we do want it to replicate. We do want it to deal with replication so that everybody that's playing would actually see the guy burning from the fire arrow. So that's one thing that we want to set. Now there's a possibility here where we could be very specific in what we put in the C++ class, or that we have to develop and place in Blueprint. We're going to start with the very basics, and we're going to just have this C++ class have basically a default scene root, scene component. So we're going to only do a set root component, and we're going to create a default subobject, and we're going to take it of type u scene component, and we're going to just call it the scene root. Okay, so that'll just give us basically the transform spot in the center. I think that's all that gives us. Everything else we can add in Blueprint. So we can add meshes or collision spheres and whatever else that we need. Since we're not ticking, we can get rid of our tick event here. And if I go into here, we can now get rid of our tick event. We don't need that. We're not doing anything in begin play at the moment. But what we do want to be able to do is have this actor apply an effect to whoever came across it, right? So let's create a function that's going to do that. So it'll be a U function, and it'll be blueprint callable, because that'll be useful, because this is very basic here. And we want to do a void, call it apply effect to target. Target. There we go. And we are going to give it, well, who should it apply to? So it's going to apply to an actor, whether it's enemy or friendly. And we'll call that the target actor. And it's going to need a gameplay effect to apply to them. So we're going to use a tsub class of type u gameplay effect, right? And we'll call that the gameplay effect class. Okay, now it doesn't know what this gameplay effect is, so that's our for declaration that we need. So class u gameplay effect. Okay, so there'll be that function. Okay, so let's create a definition for that. Now what's going to happen here? So we want the ability system to apply this gameplay effect. So we should probably get the ability system component that the target, right? Because we want to apply it to the target. So let's get the target's ability system component, because then he's going to have all of those attributes and stuff that it can screw with, right? So let's get that. And so we're going to get the get a U ability system component pointer. I got to spell it right. Component. And I probably need a include for that. Let's see. Show potential fixes. Yeesh. That's a lot. Okay, I can figure that out a lot easier. So yeah, so we need our include of our ability system component.h. Okay. So component, we'll call it the target ability system component. Variable gets too long. And we're going to set that. Now there is a function library, because remember we made our own, but there's one that exists for the ability system. There's a blueprint library, which we have to have an include for. And it is, the include for that is equal to the ability system, can you guess? System blueprint library.h. So in here, it has a function called get ability system component. And it just wants to know what actor. So we want it for the target actor. So now that we have that, if something was to overlap with our effect actor that wasn't didn't have an ability system component to it, then we can't apply a gameplay effect to it. So we should probably just exit if we don't. If target ASC here returns null, we should just bail, right? So if target ASC is equal to a null pointer, oops, null pointer, then let's just return. So we'll carry on. Now, again, here I'm fighting with the idea of these check statements to purposely crash or to handle the crash differently. But anyways, if we haven't set the gameplay effect class on this object, then we should crash, right? And let's see here. Yeah. Okay. So that's what we'll be doing for that. Okay. There's a bit more to do that once we get there, but right now this function is basically just saying, hey, if you pass me this, I will apply it to this. So that's what we're working on. So if I'm just going to come down here a little bit, give myself some room, because the target ability system component, it has a function that says apply gameplay effect to as a spec to self or to a target, um, you know. And so the spec is basically um, a handily type thing of the actual gameplay effect. So I think it's a a simple way to carry things around. So we're going to apply the effect spec. Um, we're going to apply the gameplay effect spec to self, right? Because we're looking at the target actor, right? So this ability system component is on the target already. So now we're going to apply it to it. And what does it want? It wants the gameplay effect spec and a prediction key, which I don't know anything about yet, but apparently it has to do with um, latency between server and clients and stuff like that. When I know more, you'll know more. Um, but it's optional, so we don't need to worry about it. So what we need to be able to do is create this gameplay effect spec. So how do we do that? Okay, so that's what we got to put in here. I can call it something, it just won't exist yet. No, that's not called something. So it needs a gameplay effect spec. And so if I was to, let's see here. If I looked at the target, because it's got all sorts of wonderful good things in it, the target ability system component, and I said, hey, I need a spec. Let's make one. Make outgoing spec, right? And what does it need? Well, it needs a gameplay effect class. Well, we passed it one of those, so let's give it that. So let's pass it our gameplay effect class. So we got dealt with the first one, and then we need a level, which we haven't defined anything yet. So I'm just going to put a 1.f here for now. And it needs a gameplay effect context handle. So the context, in other words, like anything in literature, what's its context? Where is it? What's going on with it? What's some of the information that it should have to track and use? So we need one of those. Well, if I said, well, what does the target do that? Does the target ASC have something for that? And I said, I want to make an effect context. And it says, okay. Okay, so we should, so this returns a context handle. So let's create one of those. So let's give this, let's assign this to an F, space bar here, gameplay effect context handle. And let's call it the effect context handle. And we'll set it equal to that. So this target ASC now, its final item here was looking for a context handle. So let's go effect context handle. And it goes, okay, I can deal with that. Now, one thing that we're going to want to be able to set on this target, on this context handle, is kind of like who created it, or what was its source, right? Because we're going to want something to track that for removals and stuff later. So if we said the effect context handle, we can add source object. So we can say like it says here, sets the object this effect was created from. That sounds like a good piece of information to set on this thing, which is this object. This effect actor has created this object. Okay, which kind of makes sense, right? So that gives us this outgoing spec. I mean, this outgoing spec creates an F gameplay effect spec handle. So let's set that, right? So let's make an F gameplay effect spec handle, and we'll call it the effect spec handle, and we'll set it equal to that. Okay. And then this target ASC gameplay effect spec handle, it actually yeah, I think I'm there. So it wants the gameplay effect spec, not a handle, but a spec. So inside here, I'm just gonna make it pop those up again. Inside of here, the control space or something like that. Inside of here, if we tried to start with the effect spec handle, right? That's the handle. Inside the handle, there's a thing called the data, and that gives us the internal pointer to the effect spec. And it's the effect spec that we want. So if we grab the data, that gives us a reference to the pointer. And now if we use get, that will return the pointer to the effect spec that the data was holding. But that is a pointer, and this effect spec thing wants a reference to it. So we need to do this magical C++ thing of dereferencing the pointer to get the reference. And if I look at the here, it wants it to be a constant. So up here, we can make this a const fgameplay effect spec handle, and then we've got this. Okay. So this returns an active gameplay effect handle. And we should probably, I want to use that one more step. So I'm going to make an F active gameplay effect handle. I'm going to call it the effect handle and set it equal to this. And that's all I'm going to do right now. Well, okay, so that does that. As strange as it is. Okay, so guy's walking along. Somehow this gets applied to him. He does have an ability system control component, and it's not null. And everybody's checking out. Everything was set up properly. Um, we found out who did this to him, and which is this object is doing it to the actor. We create the appropriate information that it wants to be able to apply it, and then we apply the gameplay effect to our self as the target. I don't know why this hasn't colored in yet, but probably because it's still waiting for something. Oh, probably because um, we forward declared it on the other side, but we need to include our gameplay effect.h. I'm pretty sure. Yeah, it's colored up now. Okay, so let's think about how this gets applied. Um, if we go here and we basically want to apply when we overlap and we want to remove it when we end our overlap. So let's make two blueprint callable functions, just two again to make it more simple maybe to apply in the future when creating for designers, or when you're designing your all the different things in your game. You don't want to necessarily always be back and forth into C++, but we want some things to give us some abilities in blueprints. So I'm going to make a U function, and it's going to be blueprint callable. And it's going to be a void function, and it's going to be on overlap. And it wants an A actor, and it's going to be the target. Okay, I'm going to make another one. And it's going to be a void function, and it's going to be the on end overlap. And again, it's going to be the A actor of the target actor. Who stopped overlapping with me? Okay, so let's create those definitions. And also, I guess we can start with the overlap one. So when we overlap, we want to apply our effect to the target, our function above, and we want to apply it to the target actor. And we need to give it a gameplay effect class. Well, we don't have one of those yet. So what do we do here? So let's go back to our .h and define some of that. And so I want to be able to define three different types of types. So an instant one that has a duration, and an infinite one. And I want those to be selections in our blueprint. So let's create some U properties here. Okay, so I'm going to create a U property. And it's going to be edit anywhere. And it will be blueprint read only. And let's put it in a category of our applied effects. Okay, and so this first one, it's going to be a T subclass of a type of U gameplay effect. And it will call this one our instant gameplay effect class. Okay. And I want those other two as well. So I'm going to copy that and I'm going to paste it twice. And I'm going to call one a duration gameplay effect. And I'm going to create another one for infinite gameplay effect. Okay, so now I have three different kinds. So if I go into here, um, you know, if I instant gameplay effect class, well, that's great. But what if I overlap one of the other ones? So we need to have some conditional statements in here. So let's set those up. And so what do we have that can that can determine what type of item this is, right? In our .h, we had application policies, and we had it's confusing me a little bit here because I haven't defined something yet. So we need not only the class, but we need to know. Um, so what we started off with these enums of our application, our effect application policies of when what to do. Um, should we do something when it overlaps or end overlaps, or when we remove it on end overlap or whatever? So we need to kind of give this class, this object, when it's ultimately defined, what policy do we want it to do something when it's on overlap? And if we do, then we can check that here on the overlap case. We could say, hey, is your enum on overlap? And we could say, yeah. And you go, well, okay, well, if that's the case, then let's apply your infinite class, infinite effect here, or your instant effect, or whatever you have, right? And it could apply all of them, right? You could, the arrow could hit them and give them 5 points of instant damage, give them a fire damage for 5 seconds, and then infinite damage. It reduces his charisma by one forever. It's like he's got a rain in the eyeball, right? Um, so this object can have a lot of variability. So let's we need to give it a way to be able to set what to do for each of these gameplay effect types of instant, duration, or infinite. So we're going to make another U property. It's going to be, I'm going to copy it from above. And this one is going to be a E effect application policy. And this is going to be our instant uh, effect application policy. And that's going to be equal to we're going to set it as a default one, E effect application policy, and we're going to set it to do not apply. Okay, I'm going to copy that one. Actually, I'll copy both these lines. I'm going to come down here and paste it in there. And I'm going to change instant to duration. And we'll set it to do not apply. And then we'll come down here and we'll change instant to infinite application policy, and we'll set it to do not apply. And the only one, I'm going to make one more here. just because this, I'm going to copy this one here and I'm going to paste it. The ones that are duration, they're going to expire after a certain period of time. The instant ones are going to happen instantly. The infinite one is only one that is has a potential of not applying on the end overlap. So this one is going to be the infinite effect removal policy, and it's going to be an E effect removal policy, and and did I spell that wrong? E effect removal policy. E effect removal policy. Do not apply. I guess it actually is looking up at it. No, didn't like that. Oh, because this, I need to change the type over here. Removal policy. Okay. Okay, so now we'll have a class, and we'll in the blueprint we'll also say how is it to be applied, right? And it can be multiples of that. So now in here we can check, right? So if we want to apply our instant gameplay effect class on overlap, then we can check if the instant effect application policy is equal to the apply on overlap, right? Then then let's do it. Then we can apply the instant one. Similarly, if the duration effect application policy is apply on overlap, right? Then we want to apply the effective target for the target actor, but we're going to apply the duration gameplay effect class. And those will all be defined in the blueprint. And again, for the infinite one, it's much similar. So the infinite effect application policy, if that is the effect on overlap, then we will apply effect to target for the target actor. The E effect application policy apply on overlap. No, no, I want to apply the infinite gameplay effect class. Okay, so that deals with when we overlap. So now when we end overlap, we want to do stuff. So here we're end overlapping. So let's create that definition now. So when we end overlap, again, we're going to check. I'm going to just copy this. A lot of it changes, but we're going to check the, I guess we're going to check the application policy. effects. Right. I guess you could have or might want, right, that it doesn't happen when you first step into the scary area. It's not the effect doesn't happen until you end the overlap, right? Just to mess with people. So this statement is just as applicable. So if the instant effect application policy is apply on, not on overlap in this case, but if we want to apply that instant effect on end overlap, right? Because that's an option that we gave to our application policy, can be on overlap or on end overlap, right? And so on end overlap, we might want to apply to the target the instant gameplay effect. Similarly, for the duration one, maybe you don't start to look ugly until you leave the ugly pool, right? And similarly for the infinite one, it might not apply until you leave the affected area, right? And then we have the one special one, though, is for the removal policy on end overlap. That we would want to check here as well, because this one's going to be a little bit different. So we'll check that if the infinite effect removal policy is equal to the E effect removal policy apply on end overlap, because we're in the end overlap function here. If that's the case, now what do we want to do? Well, to remove an infinite effect, there's all sorts of interesting things that these gameplay effects can have. They can be stackable, and they have all sorts of buttons and tweaks in them, which we'll look at when we get into the blueprints. And to be honest, this gets confusing. So I'm going to just think about it that the gameplay effect, I think it's not stackable at this point. And when you leave it, it removes its effect, right? And so how do we do that? Well, like everything else, we start with getting the ability system component. So just like up here, I'm going to do this. I'm going to get my target ASC from our target actor. And since it must have already applied to him, he must have one. But we should make sure it's valid. So I think this statement is a little bit different in this case. So if it's not valid anymore, I don't know, maybe the character died in there, maybe something like that. Something else happened. But if it's no longer valid, then let's get out of here. If it's not valid, then I'm missing a bracket here. If it's not valid, then let's get out. Okay, so now we've got a valid one. And now what I want to do is find all of the gameplay effects that this source applied to this actor. And then we can remove them. Because if I look at the target ASC, it has a function called remove active gameplay effects. Active gameplay. Remove active gameplay effect. And it wants an effect spec handle and the number of stacks to remove. -1 will remove all stacks. And this is where it just gets confusing of how it defines a stack. And well, maybe some more testing and I'll understand more about that, and maybe you will on your own as well. But if I just said, okay, I want to remove whatever test spec that I'm going to have as I'm looping through and finding them, and I'm going to just remove the one stack because I think it's only one stack higher. I'm not sure exactly. So this test spec has to be a has to be a it's here, a active gameplay effect handle. So, and I want to be removing them all. So I'm going to go into a for loop to do that. So I'm going to get F active gameplay effect handles. I don't have any of these yet, but we're going to pretend that we do. I'm going to call it test spec. And I want to loop through all the active effects, right? Which I don't have yet. But I want to do that for each one of these. Right? So for each one of these active effects, we're going to remove it. We just need to get those active effects. And how can we get them? Well, again, we'll look at the target ASC, and it has a function of get active effect, get active effects. And what does it want? It wants an F gameplay effect query. But it returns a list of all the active effects for a query. So I'm going to say, okay, well, I'm going to find one of those. I'm going to stuff it into something. I'm going to call it the effect query. I don't have that yet, but I'm going to, right? And I'm going to, and this active effects returns a T array of F active gameplay effect handles. So that's what I'm going to set this equal to. So I'm going to say my T array, I'm going to just make myself a space here, T array of type F active gameplay effect handle, right? And we called it our active effects that we stuffed into our for loop just below us. We're going to set it equal to that. Well, that's great, as long as we had an effect query. Active effects. Okay, so that made this line happy. This line here isn't very happy yet. So, well, what is one of those? So let's just make one. So it's an F gameplay effect query, right? And I'll just call it effect query. Okay, so now I've got one. It doesn't have anything set to it though, right? So it's not gonna pare down the list of all the effects. But what we know is we want all of the effects that this actor applied to the target actor. And if you remember up here, when we set our context handle of this effect, we said the source was this actor. So we're going to use that here. So we're going to, on our effect query, we are going to say with the effect source equal to this. So that'll be our parameter in our effect query. There's other things that you can apply into this. And to be honest, I'm not too sure about all of that. But I do know that this works, and it can get more complicated as needed, but I think this is good for now. So this, when we end our overlap with an infinite object, an infinite effect, we will go in and get all of the ones that this actor applied, and we will remove it because it should find it. Honestly, I think it only will ever find one, um, unless it's set to stack, and then it might remove the full stack of them or not. Yeah, that's some gameplay to testing to figure out a little bit more of that. But this is where that's going to happen. Now, could we remove a thing on overlap? Like you walk into a healing pool? Maybe, but maybe that'll just be an infinite effect that applies to the target that's going to because it would be on that healing pool. That healing pool might um, have the ability to remove effects. Yeah, I'm not sure. That's too much for me right now. So now we've got this. Do we need anything else? Well, what I would like to be able to do is like right now we hard coded this 1F. So let's just change that. Let's expose a variable for that. Um, and let's just do that right here. So let's make another U property here. I'm going to copy this one and I'm going to just call it a float, and it's going to be called the actor level. And I'm going to set it to 1.f as a default. And now I can grab this actor level variable, come over here, and I'm going to put it into there. So now that will be something that could be set on the effect. So we could say, hey, this is a level 10 fireball, right? And so it's going to apply with whatever that does, right? And so that's going to be a thing. And the other side of it is after this gets applied to the target, um, like if you think of a fireball, the fireball hits the other guy, well, the fireball disappears, right? So we want to destroy this actor. But in a case of standing in a pool of lava, you don't want to, after it applies the effect to the target, to destroy the pool of lava. So we wouldn't want to destroy the actor of the pool of lava at that point. So let's add a variable that will give us that option. I'm going to copy this new property again, and I'm going to make a Boolean that is be destroy on effect removal. I'm going to default it to false. So generally, we're not going to be removing effects unless we click the box. Okay. But what I want to do now here is after we've applied the effect to the target, is I'm going to check that if our Boolean destroy on effect removal and to make sure that our effect handle was successfully applied. Yeah, do I want to do that? We'll think about it here. Then we'll destroy. We'll call destroy on the actor here. So if the effect wasn't successfully applied, if the effect was not successfully applied, but it was, I wonder if this should be or. I think this should be or. So if we If we get through applying the effect to the target and the effect was successfully applied, then we can destroy the actor. If we get through here, but it wasn't successfully applied, um, then but it was supposed to be removed, then I think it should be destroyed because it shouldn't just persist. And if it's a projectile fireball or whatever flying along, it shouldn't just keep on going. Um, I think that should be an or. I'm gonna put a little comment here. Check or confirm conditional to be or and. Just a little reminder there to, if we get some strange things, we'll come here and we'll find that. Okay, so that's, I think that does up our effect actor. Um, yeah, I'm going to try to compile this and see how much it yells at me. It's the first one for the day, so it might be a long running one. We'll see.